Hello students, in the previous lecture we have discussed about the ceiling circuit. Okay, now in this lecture we will discuss about the ladder and wiring diagram for dual starter with the overload relay. Now, what is dual starter? Dual starter stands for direct online starter. Now, what exactly happen in case of direct online starter? We are directly connecting the motor to the supply. Okay, but it has certain protection also. It has overload protection. Okay, so when you can set the overload that 20%, 30%, 40%, 50% with this one, and if the rating is more than that, then it will disconnect the supply. And it has no voltage protection also. If voltage is not there at that time, the machine is disconnected from the supply. So basically, if you are going to observe, the dual starter seems to be like this one. It has two push buttons. One is green color push button and second one is the red color push button. The green color push button is called as the on push button and red color push button is called as the off push button. Now, green color push button, that is used on push button, is always NO type and stop push button is also always NC type. You can see you can observe over here as the metallic white color strip over there. This metallic white color strip is used for protection purpose. If you can just lock this one, this strip you can just press on this one red push button, so that even though you are going to press the start push button, the motor does not operate. So this is the additional safety features which is provided in the dual starter to avoid the starting of this starter or motor by your kids or someone. Now, if you are going to open this dual starter, inside that you can see this is a contactor over here. Okay, this is the electromagnetic coil over there, a plunger is there, and this is a contactor circuit, and this particular is called as the overload relay. Here you can set the overload percentage. Now, when you are going to press the start push button, at that time the contactor coil get energized, and once the contactor coil get energized, it will attract the plunger and it will make the contact. Okay, now here you can see the wiring diagram of this dual starter. In this is basically your main contacts of the dual starter. Dual starter has two types of contact. One is the main contact and second one is the auxiliary contact. It has main contacts for three phases: R phase, Y phase and B phase. Okay, this is my R phase, this is Y phase and this is B phase, which is connected to the motor winding. This is connected to R, Y and B. Now, when the contactor is get energized by pressing the start push button, at that time, after when you are going to press the start push button, the circuit get complete through the coil. This coil get energized. Once the coil get energized, it will produces the electromagnetic field, and because of this magnetic field, this plunger get attracted towards this. When these plungers get attracted, your supply is connected to the motor coil, and the motor get energized. Okay, and the motor start working. Now, when you're going to, if you want to stop the motor, you're going to press the stop push button. After pressing the stop push button, your circuit get disconnected and the motor will stop. Now we'll discuss the the ladder diagram for this dual starter. Here, first we will discuss the control diagram for the dual starter. This is my phase wire. This is the neutral wire. To the phase wire, I have connected one start push button. Then in series with the start button, I have placed the stop push button. Start push button is always NO type and stop push button is always NC type. Okay, so and then after I have connected a coil. When I want to start the motor, I will press the start push button. So when we are going to press the start push button, the current will flow from L1 to start to stop to coil. The coil get energized. The auxiliary contact of the coil is connected in parallel with the start push button. Okay, so even though you are going to release the start push button, the current will flow through the alternate path. That is the auxiliary contact of your contactor, and the motor will start. You can see over here the working of the motor. Now, how to draw the ladder diagram for this one? So I have selected one start push button. Then my start push button is a XI C type, examine if closed. Then stop push button is XIO type, examine if open. Then I have taken one overload relay contact over here, and this is my output coil. Now, as the start push button and stop push buttons are momentary on type, so what you have to do, if I'm going to press the start push button, my motor will start. Okay, but when I'm going to release the pressure from that button, the motor will stop. And if I want to maintain the motor in the start position or in the working position, I need to place auxiliary contact of the contactor in parallel with the start push button. Okay, so we will see in the simulation by using the software that is Logosoft. Okay, so here we will draw the ladder diagram for this one. So I will take one start push button over here, and we will change the simulation type as the momentary push button, and we will name it as a start push button. Then we will take stop push button. Stop push buttons are always NC type. Okay, its simulation is also momentary push, that is make, and its name you are going to change to the stop push button. Then we will take one more, that is overload relay, that is I3. Its simulation is also momentary make, and its name is OLR. Overload relay, its simulation is OLR. Then we will take the relay coil over here, and we are going to connect all these. Now we'll check in the simulation. Now when I am going to press the start push button, my motor will start. But when I am going to release the pressure from this, it will stop again. Okay. So the motor will start as long as the button is pressed. But for that purpose, the one hand of the operator is always busy. Okay. So he is not able to work properly on the machine. So what you have to do, we need to place a seal-in contact. So in that case, I am going to place one auxiliary contact of the output or contactor in parallel with the start push button. So I have placed one auxiliary contact in parallel with this one. Okay, now we'll check the simulation for this one. Say now I have pressed the start push button. Now the motor is start. Okay, how the current will flow? The current will flow from phase to the start push button, start to the stop, which is NC type, then to the overload relay through your contactor coil. Contactor coil get energized. As the contactor coil get energized, its auxiliary contacts close, which is the NO type, which will close now, and the alternate path for the current is through Q1 to stop push button. Okay, now even though you have released the button, the machine will in the energized state only. If you want to stop the motor, what I am going to do, I will press the stop push button. Okay, once the stop push button is pressed, the motor get de-energized, the coil get de-energized. Okay, if the power is restored, then the machine does not start directly unless and until the operator press the start push button. Okay, so this is the main advantage of your DOL starter. During no load condition, when the no volt it will give the protection against the no volt protection, no voltage. So when the voltage is not there, at that time it will disconnect the circuit, and even after restoration of the power, it does not directly start the motor unless and until the operator pushes the start push button. So it will also provide you the protection against the overload if by certain reason my machine get overloaded. So overload relay coil get energized. Okay, and once it will energize, it will disconnect the supply and the machine will get de-energized. This is basically the working of your DOL starter.